In the pickup line at my youngest son's school. It's actually the same school that I went to when I was a kid. It's kind of fun to get to be generational. It really looks the same. It's kind of funny. Let's talk about research. When I was in college, I was under the impression that in order to get into a good medical school, I had to have done research. So that means you spend either your junior or your sophomore summer doing research with a PhD and learning lab techniques in your area of training. I was a biochemistry major and a biology major, so my natural inclination for research would have been with DNA, RNA, and infectious disease. So I actually did not do research between my junior and senior year. I actually did it between my senior year and my first year of medical school. And I worked with a wonderful PhD that was doing research on the second most common cause of parasitic illness in the world, which is something called schistosomiasis. It's a mouthful. It's basically a parasite worm that enters into your body either across the skin or by ingesting and crossing into your bloodstream through your GI tract when you drink something. So you drink contaminated water, or it infects through your skin from contaminated water. And it affects a lot of places all over the world. It affects millions of people, and it's still a problem. We have great medicines for it. The most common that we used to use 20, 30 years ago was something called praziquantel. Yeah, it's a mouthful. They probably use some of the newer medicines that are anti-parasitic, maybe even ivermectin. So here's the thing. In doing research, you sit in a lab and you work with materials that are incredibly fragile, DNA, RNA, and you're trying to isolate the gene that codes for a expression on the surface of the worm, because schistosomiasis is a teeny tiny worm. And what we're trying to do is teach our body, the human body, or in this case, the body of a mouse, how to recognize and destroy this worm by recognizing a piece of the outside of the worm. Now, that was hard to do. We were trying to isolate an enzyme that helped create a certain type of sugar on the surface of the worm that's very unique to the worm. It's called fucose, Fucose. And this is what real research is you're looking at a gene, you're trying to isolate it, you're spending hours and hours, and let me tell you, doing reverse transcriptase PCR and doing DNA polymerase chain reaction, doing Western blots, putting the DNA into the electrophoresis and making the gels and doing all these things. It's labor intensive. I spent hours just prepping things. I spent half an hour just cleaning the surfaces, because everything on the surface degrades RNA. RNA and DNA in particular are very susceptible to degradation in the outside world. When they're inside of our body, there's processes to get rid of them, but they're a little bit safer, and the newer mRNA technologies coat the mRNA to protect it from the outside world. So RNA is particularly unstable, not unstable like kaboom, but unstable in that it falls apart. So these things fall apart. They don't stick together. You have to understand, from somebody that's done research and worked with these materials, they're not sticking around. They're very safe. Your body degrades them. So if you want to talk about I'll talk about research. I'll teach people about all these things, but there you go. Research.